Hi, this is Integration by Parts practice problems using the Indefinite Integral Part 2. First, I understand that there's tons of tutorials out there. Therefore, if I can't be a help, then I'd highly recommend you checking out Professor Leonard, who was an extraordinary supplement to my calculus classes, Professor Dave Explains, Organic Chemistry Tutor, Patrick JMT, and others. Links should be in the description below. I am fully aware that I may not be able to reach every single person watching this. I'm definitely not proclaiming that I discovered a breakthrough in teaching, nor am I the best tutor in the world. I just simply want to help out the best I can, and teaching is my passion. So, let's get started. We have the indefinite integral of sine inverse of x dx. And I had said in a previous tutorial that what you want to look for is a product. And here it's not so obvious that there's a product. You technically only see one function. Okay, but try integrating sine inverse of x. And you can't really do that. I mean, you could differentiate sine inverse of x, but can't really integrate that as easily. You can't do a u sub at the moment. So just try integration by parts. And if it's not apparent, then it will be in a couple of moments. First, let us recall what the formula is, which I derived in a previous video. It is the integral of u dv equals uv minus the integral of v du. Okay, so we want to find here, we want to find a u and we want to find a dv. Well, u should be something that we could differentiate easily. And of course we could differentiate sine inverse of x easily if we remember from Calc 1, which I'm not going to derive it, but first step is let u equal sine inverse of x. But where in the math problem is a dv? Well, cover up what you used for u, and what's left over will be dv. And indeed, our dv is going to be dx. Because this is a product. This is sine inverse of x times 1 dx. So our dv is going to be 1 dx. Okay, now we differentiate our u, we call it du, and if we remember, I'm not going to derive it, but if we remember from Calc 1, the derivative of sine inverse is going to be 1 over radical 1 minus x squared dx. Our v is going to be the integral of dx, and the integral of dx is just going to be x. Now, recall from my previous, part 1 of this tutorial, is try to always set it up like this because it will be easy to visually see. This is u dv. We have u dv right here. It's going to equal u times v minus the integral of v du. We have u, and we multiply it by v, okay, and then we subtract it by the integral of v du. And that's always what you have to, how you could easily do it. Okay, so this right here, or this right here, is going to equal uv, which is x times sine inverse of x, minus the integral, the indefinite integral, v du, which is right here. So 1 minus x squared over x dx. So I just multiplied it, didn't forget the dx right here. And so now how would we solve this? The integral of that. Well, now we could use the u substitution right here. Let's have u equal the radicand of the denominator. So we let u equal 1 minus x squared. And when we do that, its derivative of a constant's 0. The derivative of negative x squared is negative 2x. And don't forget the dx right here. So I'm going to divide both sides by negative 2. I have negative 1/2 du equals x dx. And what do we have here? We have an x dx right here. So we could substitute that for negative 1/2 du. Okay, so that's so far x sine inverse of x. Okay, just copying that down. And that's going to be subtracted by, I won't skip steps. Okay, I'll just do x dx turns into negative 1/2. Now that that 1 minus x squared becomes u, so it's going to be 1 over u times, I'm going to write radical u as 1/2, okay, but it's the same exact thing. This is rad u, okay, and so that equals u to the 1/2, and then du. Okay, so that negative 1/2 du right here equals x dx, which is right there. Okay, now this equals x sine inverse of x. This is how it could be tempting to skip steps, which wouldn't be wrong if you just put plus 1/2 times the integral, because negative 1/2 is a constant. It could be pulled out, and when you get really good, you could not have to write this additional step right here. So I just pulled that out. Okay, the negative and the negative turns it into a positive, and what we're left over is 1 over u negative 1/2. Okay, now to make it easier, I'm going to raise u to the numerator, and when I do that, I have to negate the exponent. Okay, du. That way, when I do the power rule for u negative 1/2, okay, that u negative 1/2, using the power rule, you add 1, and then you put it over what the exponent was added by 1. That equals u to negative 1 plus 2 is 1/2 over 1/2, which you could just recognize it easily by, you could just put the 2 right here, like this. Okay, and that's going to equal to rad u, and that is what that is right here. So what we have so far is x sine inverse of x plus 1/2 times the integral of u raised to the negative 1/2 du, which we already solved right here. So that's going to equal 2 times the radical of u. Now u equals 1 minus x squared. So this is the same as substituting back in the radical of 1 minus x squared plus c, which we cannot forget because we are dealing with an indefinite integral here. Okay, so obviously that's going to cancel, and what we're left with is, okay, x sine inverse of x plus 1 minus x squared, the radical 1 minus x squared, plus c. And that is the answer. And I'm never tired to say this, it just takes practice, dedication, and perseverance. Whatever it is in your life, whatever your major is, whatever you want to do, if it's truly in your heart, if you're truly passionate about it, then just don't give up on it. Never give up on your passions. And it takes time and practice, but it has a big reward in the end. So thank you and have a nice day.